Hello friends, let us start with the first unit of advanced function. So this unit is about the polynomial function. So first we need to understand what are the polynomial functions. So you can just do this prerequisite skill. These are very basic questions. Go through them. Just we look into polynomial function. So any function which have this form, you can see here, this form. It's called polynomial function. So what it says actually that the n value means the power of the x, it has to be a whole number, and then it has some coefficient values. So this value like n, it cannot be decimals, like you can't have values like say n equal to 4.5, then that means it's not a polynomial function. And also n cannot be, it cannot be negative. So if you say x raised to power negative 2, it's not a function. It's not a polynomial function, sorry. Okay, so you can go through this where n is a whole number, x is a variable. The coefficients, they are the real numbers. So again, they should not be radicals. Like you cannot have something like say square root 2 and then x. Okay, so polynomial we want to have a real numbers or they have some real values. Okay, so they should not be never terminating numbers. And the degree of the function is the exponent of the greatest power of x. So what it actually means, say we have a function like say I have written function say 2x plus 3x square plus 5x cubed plus say 20x raised to power 7 and then I say 30x raised to power 4. So irrespective of how your terms are appearing, you need to look into the term which has the highest value of the x power. So you can see here this is the term. So here its degree is 7. So we'll say degree is 7 and its leading coefficient is the coefficient of the highest degree term. So here leading coefficient is value 20. So normally we don't write polynomial function like this, but in case you see some function randomly put in this order, then again you have to look for the greatest value of that particular term. Okay, so go through this, and now they are saying that match each graph with the corresponding function and justify your choice. So I just want to tell you what actually how we can figure out that what graph is it or what kind of function it should look like. So I will just write here for you. So there is for polynomial function we can figure out that how the graph should look like. So any polynomial function, you can figure out how the graph should look like. So let us take example number 1. So we are going to say here degree is even and leading coefficient is positive. If this is the case, your graph will always go from quadrant 1 to quadrant 2. This is how we write quadrant. So your graph should always be going from quadrant 1 to quadrant 2 and it can have any form. The only thing is it should start from quadrant 2 and it ends at quadrant 1 if the degree is even and leading coefficient is positive. Now if the second case is if the degree is even but leading coefficient is negative, so then the graph will just look the opposite of that. So you can see that graph should look like it, and I think you know it that when the leading coefficient is negative, that means it's a reflection about x-axis. So a typical example of this graph could be like I'm just writing here, say maybe y equal to 2x square, and here it will be maybe like minus 2x square. Just taking some hypothetical example. They are not exactly representing this function, but I'm just giving an example. Okay, so something like maybe like sorry, I think I can write here negative 2. That looks slightly better. And similarly, I can write here plus 2. That looks slightly better. Okay. Now, third case is, so degree is odd and the leading coefficient is negative, positive. If the degree is odd and leading coefficient is positive, your graph should always go from quadrant 3 to quadrant 1. So it can have anything, but it should go like this. So this is quadrant 3 and it's going to be quadrant 1. And if it is other way around, so number 4 is degree is odd but leading coefficient is negative, then it should have kind of behavior like this. So it will go from here and it will come out here. So it will go from quadrant 2 to quadrant 4. Okay, and a typical example for this could be like, say, I can just write here y equal to negative x cubed plus maybe like 5. And here I can write maybe y equal to, again students, these functions which I'm taking, they're not essentially representing the graph. It's just maybe like say y equal to x cube or something like that. Okay, so now there is also one more term, student, that we study. It's called end behavior. End behavior means how the function will behave at its extreme points, and we always consider domain. So extreme domain, how the function is going to behave. So I will just take one or two examples just for you to understand this concept. Let us take an example of this graph. So say we have this graph here, and you know this side is x and that side is y, and obviously this is negative y and that's negative x. And this side we say it's going towards negative infinity, this side it's going towards positive infinity. Similarly y here it goes towards positive infinity, here it's towards negative infinity. So end behavior means what? So we'll say that when x is going towards negative infinity, means it's heading toward this side, what is happening to y? So you can see from here y is going to positive infinity, so you're going to say y is going to positive infinity. And similarly when we say x is going to positive infinity, then y is going to positive infinity. So that's the end behavior of this graph. Okay, if I take another graph, let us take an example of say this kind of graph. Again, you should know this is odd degree function with the leading coefficient negative. So again, you can just mark for your understanding x bar, and this you can say y. Now you should be agreeing with me when I say x tends to negative infinity, y is going towards positive infinity. When I say x is going towards positive infinity, y is going towards negative infinity. So those are called end behavior. Okay, and with respect to these graphs only, we can also talk about something more. We call it, let us look into those terms. So we call number one is positive function. Positive function means what? Fx, we call it positive when fx value is greater than 0. Okay, so we have to figure out when this function is positive, and similarly it is a negative function when fx is less than 0, or you should say it's negative, and here you can say fx greater than 0. So then it will be negative. Now what it actually means, so again take an example of some graph, some random graph, and just I'm putting some values here. So let it be negative 2, this is say let it be 1, and then let it be say 3. Now you can see this graph has been divided into different interval, and that's how we write it: negative infinity to negative 2, and then negative 2 to 1, and then 1 to 3, and then 3 to infinity. Those are the different intervals of this particular function. Okay, you can see it is divided on the basis of the x-intercept we have. Now if you look into negative infinity to negative 2, all your values are below 0. That means here the function is negative, and it is always alternate, students. So here it's negative, now it's positive. You can also see all the values for this interval, they are above 0, and 1 to 3 again it's negative, and 3 to infinity again it's positive. So this way you can also find whether the function, where the function is positive, where it's negative. And there is another thing, when the function is increasing, when the function is decreasing. So these are two different terms. Okay, so just look into, I'm taking the same example. So I'm going to say this is my function, Let's take the same values, -2, -1, and I will say here let it be 3, and just for better understanding I'm going to mark this point as 2. Increasing means when the x values, whatever are the x values, the y value is increasing. Okay, so if you see this graph, let us first talk about increasing. So if you look into this graph, let me have some different pen. So you can see starting from this point up to almost that point, the function is increasing up to this point, and then it start falling down, it start decreasing up to that point, and then it increase afterward, it's going up. And another way you can also see, when the slope is positive, the function is increasing. When the slope is negative, the function is decreasing. So if I have to see where the function is increasing, I will say -infinity to 0, the function seems increasing, and then from 2 to positive infinity. That's here the function is, and you can write here and sometimes we also write u. U means union. And where it is decreasing, so decreasing the remaining alternate interval. So you can see starting from 0 up to 2, the function is decreasing because its slope is negative. So these are some of the terms we need to know, the end behavior. Now I'm coming back to the same terms that we just left here behind. So now they're saying match these functions with their corresponding graph. So I will just try to do 1 or 2 questions from here. So let us see this, y equal to x square. Don't look into the graph, just think of how the end behavior will look like. So you can see here the degree is even and leading coefficient is positive. So obviously it should go from quadrant 2 to quadrant 1. Look into which graph goes from quadrant 2 to quadrant 1. I can see this graph and this graph here. Okay, and I can see this graph is the graph that we have down, number 3, is very wide. So depending upon the width of this, we can decide the degrees. So more wider means more flat graph down there, it means highest degree. So I just want to tell you, if you look into this, if we look into these graphs, we can see we have 3 even degrees, 2, 4 and 6. So 2 is like parabola that you can see at the bottom. So this is degree here 2, that means this is x squared, and that's your x4, and this is x6. Okay, and then this line is, I believe this is just y equal to x, and this function should be odd degree going from quadrant 3 to quadrant 1, and its leading coefficient need to be positive. So again, I think we have those functions there, you can check them. Sorry, this is scrolling too fast, so just have a look on that. We have all those functions here. Okay, so you can look into these parts and then go through this also. This is just how to represent the things on the number line, how you can represent, like say a to infinity. And there is also one term that students you need to understand. So we have 2 types of things that we use here. One is square brackets, like I said, 2, 2, 3. That means both the endpoints are included. Endpoints are included. That means this function can take value 2 is less than equal to x is less than equal to 3. If I write a bracket like this, say 2, 3, that means extreme points are excluded. So it should be 2 is less than x is less than 3. And if I make interval like this 2 and say 5, that means what, 2 is excluded but 5 is included. Okay, so remember these things. This is the representation, and for the infinity we never write square bracket, and the reason for that is infinity does not have any definite value. So whenever there is infinity, we always like this. There is no square bracket, you can't write like this, because when you say this, that means you are sure about what the infinite value is, and you know the infinite undefined value we don't really know, so we just put simple bracket. Okay, So that's all for this part, and